Hello everyone, this is Texas Instruments Innovation Challenge India Analog Design Contest 2014. We are team number 49.3 working on a project entitled Smart Gesture Control Dual Mode Robot. We are the students of Maharaja Surajmal Institute of Technology situated in C4 Janakpuri, New Delhi. Short description about the hardware of my project. The hardware is basically divided into two parts, that is transmitter and receiver. My transmitter module consists of accelerometer sensor, MSP EXP430G2 launchpad manufactured by Texas Instruments, power supply, ST12V encoder and RF transmitter. Now the first component in this module is MSP EXP430G2 launchpad. This launchpad basically helped us in providing its onboard emulation for programming and debugging the code and using its 12-bit DAC and consisting of capacitive touch input and output. The next component is RF transmitter. This transmitter is helpful as it is centered at the frequency 433 MHz and it allowed us to transmit 8-bit of information to the receiver side. The next component is accelerometer. We have in this project used ADXL335 3G axis accelerometer. It is basically the heart of our transmitter module as this accelerometer is capable of sensing the robot directions and providing a motion by using our hand gestures and our static acceleration of the hand. The last component we have used in our transmitter module is ST12V encoder. It is a 212 series of encoder manufactured by Holtec and it is capable of encoding 12-bit of information and transmitting it serially to the decoder. Now coming to my receiver module. The basic receiver module of our project consists of RF receiver, ST12D decoder, MSP430G2553 master microcontroller. It is manufactured by Texas Instruments, motor driver L293D and obstacle detector LM324. The first component in this module is MSP430G2553 microcontroller. This microcontroller is a mixed signal microcontroller manufactured by Texas Instruments and comes under ultra low power 16-bit MCU. We have used this microcontroller in our project by using its inbuilt 10 IADC converter, which have allowed us to convert the analog data received from the sensor into the digital data. The next component we have used is RF receiver. This receiver is again centered at frequency 433 MHz and receives the information from the transmitter by using a whip antenna. The next component we have used in our receiver module is motor driver L293D IC. Now this IC is manufactured by Texas Instruments and it is the most important IC in our project as it drives 200 RPM motors and due to its bidirectional nature we can control the two motors at the same time. The next component we have used is ST12D decoder. This decoder is capable of decoding 12-bit of information and it is an 18-pin IC, again comes under the series of 212 encoders. We have used these decoders in order to easily decode the information received from the transmitter. The next component we have used is LM324 IC. Now our project is entitled Smart Gesture Control Dual Mode Robot. The reason we call it smart is only due to this IC because it has the feature of detecting an obstacle and allowing the microcontroller to remove this without changing its direction. This IC is capable of sensing the object and as soon as the object is sensed, it's transferred the control signal to the microcontroller and only due to the microcontroller the L293D is directed through which it is moved. The last component in our receiver module is power supply. For driving all the ICs in our receiver module, we have used UA7805 power supply IC, which is manufactured by Texas Instruments, containing 3 terminals, namely VCC, ground and output. Now this was all about the hardware description. Now let me give you a short software description of my project. For developing the microcontroller and microprograms in the controller, we have used Code Composer Studio version 5. It is basically the Eclipse based software and containing the suite for all MSP430 devices. It supports both Linux and Windows PC, so it provides easy installation. Now I am going to introduce you about my finished transmitter and receiver PCBs. It is a transmitter PCB and it is a receiver PCB. In the transmitter module, I have used MSP EXP430 launchpad. To it, I have connected ST12V encoder, which is a series of 212 encoders, and ADXL335 3G axis accelerometer sensor. Here, the accelerometer sensor takes the analog value through our hand movements and gives to the port 2.3 and 2.4 of the microcontroller. The microcontroller then converts it into the digital data, 10-bit digital data, and transmits the same from the port 1.0 through 1.3 to ST12V encoder. Now with encoder we have attached an RF module consisting of RF transmitter and whip antenna centered at frequency 433 MHz. As soon as the encoder receives the 10-bit information, it transmits the information to the antenna and which is received in the receiver circuit. Now coming to the receiver circuit, in the receiver circuit we have attached an RF module again with a frequency of 433 MHz. As soon as the data is received by RF transmitter, it is passed to HT12D decoder. Now this decoder is again a series of 212 decoders and is capable of decoding 12 bit of information. Through this decoder, the data is processed and is passed to MSP430G2553 mixed signal microcontroller manufactured by Texas Instruments, which using its inbuilt DAC converts the data into digital bits and stores it for further action. Also, we have used a motor driver IC L293D, which is capable of driving 200 RPM motors at the same time. It is again manufactured by Texas Instruments only. Also, we have used LM324 IC manufactured by Texas Instruments for the purpose of obstacle detection and perception. And due to this functioning of IC, we call our project as dual mode robot. With this IC, we have attached an IR transmitter and IR receiver. Both of these receiver, whenever detects an object, transmit the control signal to LM324 IC, which in turn passes this information to the microcontroller. Based on the outputs received from LM324 and HT12D, the microcontroller generates the control signal and passes to L293D IC, which in turn drives the motor in the desired direction, and hence our gesture implication is implemented. Also in the circuit we have used UA7805 IC for giving the power to all other ICs in the circuit. This IC is capable of giving 5 volts to each IC, which is necessary for driving power microcontroller and L293D IC. UA7805 IC is again manufactured by Texas Instruments only. So this was the hardware description of my finished products used in our project. Now this is my demonstration of the project. This is the reference state of the accelerometer. This is the forward turn. This is backward turn. This is left, and this is right turn. I have defined certain state. Now the accelerometer in this state is in reference state. Now, in spite of implementing all the gesture movement, my module is capable of detecting an obstacle. As you can all see that when the obstacle has been detected, it starts moving backward. Then it turns 90 degree automatically and stops. The module has been programmed in such a manner that it automatically stops when it turns 90 degree, and the user has to relaunch it by using its gesture applications due to the non-functionality of our robotic arm. We hope that this video provided a good demonstration to you all. Thank you. So this was the short demonstration of our project. We are able to implement the gesture navigation and obstacle detection in our project, but we are still working on the robotic arm feature as we are getting difficulty in implementing it through IADC protocol. I am sure that we will be given a chance by Texas Instruments to present a fully furnished project. In the end, I would only like to acknowledge my fellow friends and my faculty who guided us throughout this project and supported us.